Hey, hey everybody. So this is our second class day of the semester. So I hope everybody is well. I just wanted to start off by saying hope everyone is well, which I just did. Okay, so what I'm going to do again. So as a reminder, if you haven't enrolled in Lumen Learning, please do so. And what was I going to say? Okay, so that, again, the syllabus is still posted online. The lecture videos are on YouTube with closed captioning. So again, they're there. If you want to watch the lectures again, you're more than welcome to. Okay. All right, so let me start lecturing now. So I'm going to turn off my camera, but not my microphone. There we go. Okay, so let me get the lecture notes. I did email you guys the lecture notes. So, you have an outline of them in front of you. So I know usually when I teach face-to-face, I teach on the blackboard and then you could write down the notes, but here, of course, we're not able to do that. So let me get started. Okay, so this is actually where we left off last time. We did do some definitions last time, like lines and points. A line, remember, was one-dimensional, and it's made up of infinitely many points, if you remember, right? And one-dimensional, what does that mean? That just basically means left or right, left or right. Or if you think about north-south, east-west, east and west only. You can't go forwards or backwards, so to say. Can't go up or down, if that makes sense. Two-dimensional, however, that's a different story. A plane, so basically a two-dimensional analog of a line, if you want to say that, think of it that way. Did I not share it yet? Oh, geez, I'm sorry.
No, I don't see the screen yet.
Yeah, my fault, I'm sorry. Oh my gosh, I was so anxious to lecture. There we go, sorry about that. Okay, so last time again, what we did was we saw some definitions, right? We saw like a line, which is one-dimensional, and it's made up of infinitely many points. One-dimensional basically meaning it goes only left or right. So can everyone see it now? Good. Okay. So in other words, you can only go left or right, okay, when it's one-dimensional. And the so-called two-dimensional analog, so to say, is a plane. Now, a plane then, as I wrote here, it's a two-dimensional flat surface, and it continues infinitely, or in other words, it never ends in each direction. Two-dimensional, you can almost look at this rectangle, or you can think about a sheet of paper that's flat and it has no thickness to it. You could think of that as a plane. Two-dimensional basically means you can go right, left, or you can go up or down, right or left. Think about a sheet of paper that extends indefinitely in each direction. You could think of it that way. I'm pretty sure in high school math that is, they have you draw in the XY plane, the x-axis and the y-axis. Well, you're drawing in a plane, right? You're drawing in a plane. I mean, I hate to say there's no height because height will come up again later, but you could think of it as having no thickness. You could also think of it that way. Again, like a sheet of paper that has no thickness to it. And then we have two-dimensional figures, and those are just figures that we can draw fully in the plane. I have one over here, a rectangle, and we have another one here, a triangle. And again, two dimensions, what does that mean? Left, right, you can go up or down. You could think of it as having length, which is left and right, that's one-dimensional. Width is the other dimension. You could also think of it that way if you want. That happens with a two-dimensional figure. Now, what we can do is we can consider what are called polygons. Polygons are figures that have straight lines that are made up of straight line segments. They're two-dimensional shapes that are made up of that have straight sides. Let me say it again. A polygon is a two-dimensional figure with straight sides. It's also said to be closed. Now, that closed gets a little technical, but think of it this way. If you start somewhere on the figure, on the boundary, and you walk only in one direction on the boundary, like so, if it's closed, that just means you will get back to the point you started at. I mean, if you want, you can think of it this way also. If you're inside the figure, if it's closed, you can't get out. There's no openings to get out. Remember, you can't, there's only two dimensions, so you can't come off the paper, you can't come off the plane, so to say. But basically, that's what a polygon is. It's a two-dimensional figure made up of straight sides. Its boundary is only straight sides, and it's closed. I mean, the book doesn't really define closed. That's why I tried to define it as basic as I could. It's a little technical, but for now, what I said was enough. And perimeter is just the distance along the outside of the polygon. In other words, perimeter is just the distance around the shape. In other words, if you're walking along the boundary in one direction, the perimeter is how far you walk. That's just what the perimeter is. You know, and for a polygon, we have rectangles, we have squares, right? They're made up of straight sides, triangles as well. There's also parallelograms, which we will see shortly. So to get the perimeter, you add up the length of each of the sides that make up the boundary. The thing is, though, you have to be a little bit careful because you have to make sure the lengths